Welcome to the Copperfield Electric Podcast. Imagine this scenario for a second. You just, drop $2,000 on the absolute ultimate smart home setup.
Oh, the dream setup.
Right. You've got the automated blackout blinds, the high-definition Wi-Fi security cameras, the mood lighting that changes color when it rains.
It sounds great.
It does. And you spend your entire weekend painstakingly installing all of it, syncing the apps, feeling like an absolute tech genius.
Until Monday morning rolls around.
Exactly. Monday morning, someone in the house turns on a vacuum cleaner, and suddenly your entire house goes offline.
Yep.
The breakers trip, the cameras die, and you realize the only way to actually fix the root of the problem is to, take a sledgehammer to your pristine, perfectly painted drywall.
Which is a complete nightmare. I mean, nobody wants to be living in a construction zone, patching and sanding drywall just to get their internet to work.
Right.
It is messy, it is incredibly expensive, and the most frustrating part is that it's entirely avoidable.
Avoidable if you know what's actually hiding behind those walls, which most of us really don't.
No, we don't.
So that is our mission for today's deep dive. We are looking at a really fascinating stack of materials from Copperfield Electric.
Yeah, they're great.
For some context, they are a family-owned 24/7 emergency electrical service based right out of Tustin, California. And today, we are specifically unpacking this incredible blueprint they've provided on electrical planning for smart homes.
It's a really thorough guide.
It is. We are going to help you, the listener, avoid that drywall-destroying, budget-busting nightmare we just talked about.
And Copperfield really understands this landscape because, they're the ones getting those desperate phone calls.
The SOS calls.
Yeah, exactly. They have a massive service area covering Orange County. So we're talking Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Mission Viejo.
Wow. So everywhere.
Yeah, they see the aftermath of poor electrical planning every single day. And there's a statistic in this blueprint that really anchors everything we're going to explore today.
Hit me with it.
It's this retrofitting a house for smart technology. After the walls are closed up, it costs 3 to 5 times more than planning for it while the walls are still open.
Okay, let's just pause on that. 3 to 5 times more.
It's huge.
That's not just a minor inconvenience, or a slight upcharge. That is a completely blown renovation budget.
Right. If your smart home wiring was supposed to cost $2,000, you're now staring at $10,000 just because the drywall is finished.
So to prevent that massive financial hit, we need to start at the absolute foundation. Before you or I go out and buy a single smart bulb or automated lock, what is the very first thing we have to evaluate in our house?
We have to evaluate the main electrical panel.
The panel, okay.
Yeah, the blueprint makes this abundantly clear. You cannot run a modern automated smart home if the central power source is gasping for air.
That makes sense.
We have to establish the baseline power needs before we even think about running a single data wire. And this brings us to a concept the source refers to as the 100 amp problem.
Okay, let's unpack this. The 100 amp problem. I'm assuming this applies pretty heavily to older homes.
It does, yeah. If your home was built before the year 2000 and it hasn't had a major electrical overhaul, it very likely runs on a 100 amp electrical panel.
Okay.
Now, 100 amps was perfectly fine for the appliances and the incandescent lighting of the 1990s.
Sure.
But a modern smart home system, a true home automation ecosystem, typically includes anywhere from 25 to 40 constantly connected devices.
Wait, 40 devices?
Easily.
Let me use an analogy here just to see if I'm wrapping my head around this. Trying to run 25 to 40 connected devices, plus your heavy-duty appliances like your fridge and your HVAC, on a 100 amp panel that feels like trying to merge 40 lanes of high-speed modern traffic onto a 2-lane dirt road.
Oh, that is a great way to visualize it.
It's just going to bottleneck, right? You're going to get constant cascading traffic jams, which in electrical terms means you are tripping breakers left and right.
Exactly. People fall into this trap where they think, LED smart bulbs use less power than old bulbs, so I'm fine.
I've definitely thought that.
Right. But they aren't accounting for the sheer volume of micro draws happening simultaneously.
Micro draws.
Yeah, you have smart switches, smart thermostats, standby modes on TVs, network routers, and cameras, all just sipping power 24/7.
Wow, okay.
Integrating those technologies onto an already tight 100 amp panel pushes the system right to its limit. Which is why the solution, the magic baseline number according to the text, is a 200 amp panel.
A 200 amp panel.
Upgrading gives the house the necessary headroom.
Headroom. I really like that term. It implies like breathing space for the whole system.
Breathing space is exactly what it is. It gives you the capacity to juggle those 40 connected devices seamlessly.
Nice.
Plus, it prepares you for massive high-draw additions down the line, like EV charging, which Copperfield also installs, by the way.
Good to know.
With a 200 amp panel, you aren't constantly negotiating your power usage. You don't have to worry that turning on the microwave in the kitchen is going to somehow shut down your smart security system in the hallway.
Right. All right. So step one is clear. We upgrade the heart of the system to 200 amps so it can pump enough power.
Step 1, done.
But once the heart is strong, the blueprint says we have to talk about the brain, the central hub of the smart home.
Yes, the convergence point. In a truly planned smart home, all your data and central controls live in one spot.
Okay.
Whether you're using a dedicated smart home hub, a full network rack, or just a patch panel tucked away in a utility closet, this central brain has very specific physical requirements to survive.
Like what?
First, it needs its own dedicated 20-amp circuit. Second, it needs serious ventilation. And third, it has to be easily accessible for future upgrades.
Okay, I have to push back here a little bit on behalf of anyone listening who is currently looking at their living room setup. When you say network rack or patch panel, you're talking about the physical box where all the internet and smart home connections meet, right?
Correct. Think of like an old school telephone operator switchboard, but for your home's data.
Right.
It's where the outside internet comes in and gets distributed to all the different rooms.
Okay, so knowing that, why can't I just plug that hub into a high-end power strip behind my television, maybe next to my gaming console, and just call it a day?
A lot of people do that.
Why go through the trouble of wiring a dedicated 20-amp circuit just for the router and the hub?
What's really fascinating here is the hidden physics of power distribution behind your walls. Not all devices draw power smoothly.
Really?
No. So when you plug a crucial piece of infrastructure like your home's network brain into a shared circuit, you're putting it at the absolute mercy of every other device on that line.
Oh, I see.
Say you share that circuit with a bathroom outlet. Someone turns on a hairdryer, which contains a massive heating element.
Oh, no.
Yep. The hairdryer surges, the circuit overloads, the breaker trips to prevent a fire, and suddenly your entire smart home is brain dead.
Wow.
Your cameras go offline, your smart locks might lose remote connectivity, your Wi-Fi is just gone.
So it's about isolation.
Mm-hmm.
You are isolating the most critical system so it can't be taken down by someone drying their hair or running a space heater 2 rooms over.
That is exactly why a licensed electrician performs what's called a load calculation.
A load calculation?
Right. They look at your 200 amp panel and mathematically map out what each circuit can handle before you buy a single device.
Smart.
Mapping out a dedicated circuit just for the smart home hub prevents those localized overloads. You're designing a resilient system from the architectural level rather than just plugging things in and hoping for the best.
Okay, the picture is coming together. We've got the 200 amp panel providing plenty of juice, and we've got this dedicated, well-ventilated brain safely isolated on its own circuit.
The heart and the brain are secure.
Exactly.
Yep.
So the focus has to shift to the nervous system. We have to figure out how the data and the power actually travel from that utility closet out to the camera on the front porch or the speaker in the kitchen.
And this is where we run headfirst into a massive misconception in the tech world.
Let me guess the idea that Wi-Fi can handle everything.
That is the one. We've all been heavily conditioned by marketing to think that if we just buy a slightly more expensive Wi-Fi router or plug a few more mesh extenders into our outlets, all our connectivity problems will just vanish.
Right, like the air will just magically carry all this heavy data.
Exactly. But the source material argues the exact opposite for a true smart home. The hardwired truth is that Wi-Fi should really only be used for things that move, like your phone or your laptop.
Here's where it gets really interesting, because I think a lot of people, myself included, try to avoid drilling holes and running wires at all costs.
Naturally.
But the text is uncompromising on this. Anything that absolutely cannot tolerate a dropped signal needs to be physically hardwired. We're talking security cameras, whole home audio systems, stationary smart TVs.
Because hardwired connections are bound by physics to be inherently faster, infinitely more secure, and vastly more reliable.
Exactly.
Wireless signals constantly fight against physical barriers. Walls, mirrors, plumbing pipes, and interference from your neighbor's Wi-Fi.
Oh, the neighbor's Wi-Fi?
That's a
Yes.
mess. This brings us to what the industry calls structured wiring. According to CEDIA, which is the main industry group that sets these home integration standards, the absolute benchmark for new construction right now is Cat 6A structured wiring.
Okay, let's translate the technical jargon for a second because we hear Cat 5, Cat 6, and Cat 6A thrown around a lot at electronics stores.
We do.
What the blueprint tells us is that Cat 6A, the A stands for Augmented Guarantees Massive 10 Gigabit Data Speeds over a full, long run through a big house.
Exactly.
Standard Cat 6, on the other hand, gets exhausted, and the speed drops off steeply past about 50 meters.
Yeah.
It's like a sprinter running out of breath halfway down the track.
That's a great way to put it.
Right. If your security camera is mounted at the end of a long driveway and you use standard Cat 6, that video data is gasping for air by the time it reaches the hub in the house.
That is a phenomenal way to visualize latency and bandwidth drop-off. And because we are trying to future-proof the home, meaning we don't want to open the walls again in 5 years, the blueprint provides very specific wiring ratios.
Ratios, okay.
Yeah, it recommends running at least 2 Cat 6A drops to every single bedroom. And for the main living areas, 4 drops, all of them physically running back to that central patch panel in the closet.
Wait, hold on. For anyone who hasn't run wire before, when you say a drop, you literally mean one continuous cable running from the central brain, winding through the framing of the house, and dropping out into a wall plate in the living room.
That's right. One continuous unbroken cable.
So 4 drops per living area, plus 2 per bedroom.
Yep.
I mean, I'm looking at my living room right now, and my standard Wi-Fi router streams 4K Netflix just fine. Are we wildly over-engineering this? That sounds like a massive, expensive amount of copper inside the walls.
It sounds like a lot until you remember that 3 to 5 times cost penalty we discussed earlier.
All right.
Running extra wire while the wooden framing is exposed and the walls are open is incredibly cheap and fast. You just staple it to the studs.
Oh, sure.
Opening up finished painted drywall to snake a single new wire 3 years from now because you want to add a gaming console or a new smart TV that involves cutting holes, hiring a plasterer, repainting. It is agonizingly expensive.
Which perfectly sets up my absolute favorite detail from this entire deep dive.
The conduit.
It's so simple. It's brilliant. The empty conduit. The blueprint calls it the cheapest insurance you can buy.
It really is. If we look at the bigger picture of homeownership, technology always evolves faster than architecture.
Very true.
You can install the absolute best Cat 6 wire available today, but in a decade, there might be a totally new standard. Maybe we'll all be running fiber optics directly to our televisions.
Who knows?
By installing an empty conduit raceway, which is basically just a hollow plastic tube from the main electrical panel up into the attic and another one running to the exterior of the house, you are leaving a permanent, open highway inside your walls.
It's a secret tunnel for the future.
Exactly.
When the new technology comes out, you literally just tie a string to the new cable and pull it right through the tube without scratching a single piece of drywall.
It is brilliant foresight. Homeowners who skip the conduit to save $50 are the ones calling an electrician back in 3 years in a complete panic.
Oh, I bet.
And while we are talking about the sheer physical reality of wiring, we have to talk about the absolute magic of PoE, power over Ethernet.
I am so glad this is in the blueprint. Explain how this works, because it sounds like science fiction when you first hear about it.
It fundamentally changes how you design a room. PoE allows a single Cat 6A cable to deliver both the high-speed data connection and the electrical power to run a device simultaneously.
Through one cable.
Through one cable. Inside that single thick cable are 8 tiny twisted copper wires. PoE technology dedicates some of those tiny wires to carrying internet data and others to carrying low-voltage electrical current. So, imagine you want a security camera or a wireless access point mounted flat on your ceiling. You don't need to hire an electrician to install an ugly, standard electrical outlet all the way up there and then plug a bulky adapter into it.
Right.
One sleek Cat 6A cable does both jobs.
That saves an unbelievable amount of time, labor, and visual clutter.
Oh, totally.
But there is a catch. The blueprint warns that when you're running all these incredible data cables through the walls, they have to play nice with the traditional high-voltage electrical wires that power your house. And it gives us a highly specific, very strict interference rule.
This is a critical engineering detail for anyone doing new construction or major renovations. Low-voltage data cables like your Cat6a must be kept at least 1 full foot away from standard electrical wiring when running parallel through the walls.
And what if the architecture of the house forces them to cross paths? I mean, what if the data line absolutely has to get past a power line?
If they absolutely must intersect, they are required to cross at a 90-degree angle. They can never run parallel to each other in close proximity.
Okay, why? What is the actual physics behind that rule? Why a 90-degree angle?
It all comes down to electromagnetism. Every time electricity flows through a standard power wire in your house, it creates an invisible electromagnetic field radiating out around that wire.
Okay.
If you run a data cable right next to it, parallel, the data cable essentially acts as a long antenna. It picks up that electromagnetic field as static or noise.
Ah, I see.
Crossing at a 90-degree angle minimizes the physical surface area where the two cables interact, completely cutting down that interference. If you run them parallel, the electrical wire scrambles the data.
Wow.
And that interference inside the wall is what causes dropped connections and glitchy cameras much more often than a weak router ever will.
That is mind-blowing. So those dead Wi-Fi zones are the security cameras that constantly freeze up and you can't figure out why. It might not be the device at all.
No.
It might literally be a data cable running too close to a power line inside your wall, getting completely scrambled by an invisible magnetic field.
Which is exactly why having a professional, like the team at Copperfield Electric, physically map this out is so critical. They understand the invisible physics happening behind the drywall, not just how to turn a screw.
So we've built up the 200-amp panel, we've got our dedicated hub, we've run our Cat6 in our empty conduits safely away from the power lines.
We are making progress.
Yes. Now, we finally reached the extremities, the endpoints. We are at the stage where we are actually installing the smart switches and the security keypads into the walls.
And this is the moment where weekend DIYers usually hit a massive brick wall, particularly if they live in older homes.
Let me guess.
The single most common infuriating headache: the missing neutral wire.
Yes. Let's paint the picture. It's a Sunday afternoon. You buy this gorgeous $70 smart switch for your living room.
Very exciting.
You turn off the power at the breaker, you unscrew your old standard dumb switch from the wall, pull it out, and you realize the wiring inside the wall box doesn't match the instructions in the manual. You are missing a wire.
It happens every single day. Modern low-voltage lighting control systems and smart switches require a specific neutral wire inside the switch box to function.
Why is that?
Well, to understand why, you have to look at how old switches worked. A traditional dumb switch is basically a physical drawbridge. You flip it up, the bridge connects, power flows to the light bulb.
Right.
You flip it down, the bridge lifts, the circuit physically breaks, and the power stops completely.
Right. Simple physical mechanics.
But a smart switch never truly turns off. Even when the living room lights are totally dark, the smart switch itself needs a tiny, continuous trickle of electrical power to keep its internal Wi-Fi chip or radio receiver awake.
Oh, because it's always listening.
Exactly. It has to stay powered so it can listen for your voice command or your smartphone app telling it to turn the lights back on. That neutral wire provides the dedicated return path for that continuous trickle of power, completing a secondary low-voltage circuit just for the switch itself.
And homes built decades ago just didn't run neutral wires down to the switch boxes because standard drawbridge switches didn't need them.
Exactly. They just broke the hot wire.
So if you open the wall and you don't have that neutral wire, your fancy new smart switch is literally dead in the water.
It is completely useless. And fixing it requires an electrician to snake entirely new wire through the finished walls.
Ouch.
Again, it all comes back to planning before the drywall goes up. But, smart lighting is just one piece of the puzzle at the extremities of the house. The blueprint stresses that we also have to look very closely at security.
Well, the stakes are undeniably higher with a security system than they are with dimming your dining room chandelier.
Dramatically higher. The blueprint emphasizes that alarm panels, network security cameras, and the specific Wi-Fi access points that support them should never share a circuit with everyday household appliances.
No.
Never. Just like the central hub, the security extremities need dedicated circuits.
Which makes perfect sense based on our earlier discussion about the hairdryer tripping the breaker.
Oh.
You don't want a faulty toaster taking down your perimeter defense.
Right.
But it raises a very practical question that I think a lot of people worry about. Let's say I've done everything perfectly. Dedicated circuits, hardwired Cat6a, massive 200-amp panel.
Okay.
What happens if a severe storm rolls through Orange County and knocks out the main municipal power grid? Doesn't all this brilliant, expensive smart home planning just turn into a dumb brick when the house loses power?
That is the ultimate test of a smart home, and the source text actually accounts for this exact scenario.
Oh, really?
Yes, because you've engineered your security system and its supporting network infrastructure onto its own isolated, dedicated circuit, you can seamlessly integrate a battery backup unit specifically tied to that circuit.
Oh, wow. I see where this is going.
Yes. When the municipal grid goes dark, that dedicated security circuit automatically and instantly flips over to the battery backup.
That is brilliant.
So while the rest of your house might be completely dark and your smart fridge might be warming up, your security cameras, your alarm panel, and the data network keeping them communicating to your phone stay fully functional.
So you don't lose your home's defenses just because the grid had a hiccup.
Exactly.
That right there is the defining difference between a house filled with a few expensive gadgets and a truly engineered smart home.
It's resilience.
It is absolute resilience.
Oh, okay.
But before we finish up at the extremities, there is one more major pitfall we need to touch on. It's less about the physical copper wires and more about the invisible software. The blueprint calls it the ecosystem pitfall.
The frustrating reality that not all of these expensive devices want to be friends with each other.
Precisely. You can have the most perfect Cat6a wiring and a 200-amp panel, but if you buy a smart hub that runs on one software ecosystem, say Apple HomeKit, and you buy smart locks or a thermostat that only communicate via a different protocol, like Z-Wave or Zigbee.
They just ignore each other. They might completely refuse to communicate. You end up with 3 different apps on your phone just to turn off your house at night.
That is so annoying.
The text points out that forcing devices from different ecosystems to talk often requires incredibly frustrating software workarounds.
Which is exactly why the text heavily advocates for a professional pre-purchase consultation. Catching those paper gaps, realizing your chosen thermostat literally doesn't speak the same coding language as your chosen security system before you actually purchase them and try to force them together.
It saves you from buying expensive hardware that will never seamlessly integrate.
So we've journeyed from the 200-amp beating heart of the house through the structured Cat6a nervous system, avoiding the electromagnetic interference, all the way out to the neutral wires and battery backups in the extremities.
It's quite the journey.
When we synthesize all of this information from Copperfield Electric, what becomes incredibly clear is that true smart home planning isn't about buying the flashiest gadgets off the shelf at the big box store.
Not at all.
It is entirely about building an invisible, robust infrastructure. The panel capacity, the structured wiring, the dedicated circuits.
It is the architectural foundation that makes the technological magic possible. If you are building a new home or doing a major upgrade anywhere in Orange County, whether you're in Irvine, Anaheim, Costa Mesa, Newport Beach, or Mission Viejo, remember that Copperfield Electric handles these exact design consultations.
Which is invaluable.
Right. They do the complex load calculations, they map the circuits to prevent interference, and they stop these headaches long before the drywall ever goes up.
Because you really, really don't want to be the person paying 3 to 5 times more to tear open your finished walls because you forgot a neutral wire.
No, you don't.
Before we wrap up, I want you to look at the walls around you right now. For centuries, we used to expect our houses to do one very basic job, keep the rain and the cold out.
Right.
But as we increasingly demand our homes to think for themselves, to react to our routines, to adjust the temperature automatically, and to protect us with active surveillance 204/7, you have to wonder, in a few decades, will the data wiring hidden inside our walls be considered just as legally and structurally critical to a home's survival as the concrete in its foundation or the plumbing in its floors?
Given how fast technology is moving, it might be the most critical infrastructure of all.
Thank you so much for joining us on this deep dive. May your Wi-Fi be endlessly strong, your electrical panels be incredibly roomy, and your pristine drywall remain perfectly intact. We'll catch you on the next one.
Take care, everyone.